Here in section 2.2, we're going to look at angles formed by parallel lines. So we're going to add two more possible ways to prove that lines are parallel. And so this is going to be number 3 and number 4. Remember, number 1 is corresponding and 2 is vertically opposite. So now we have 3 and 4, and you can see that if we have two parallel lines and we have angles on either side of the transversal that are interior angles, or this orientation as well, then they are alternate interior angles. They are used to prove that lines are parallel. And alternatively, we have exterior or alternate exterior angles, and that's when we have two parallel lines, a transversal, and exterior angles on the opposite side of the transversal. So that's essentially what example 1 was going to say in the book, so we're going to jump right to example 2. Here in example 2, we have to use reasoning to determine unknown angles. So we'll start off with angle A. So we'll again start our statement and reason table. And let's start with angle A. So angle A is, if we use these two lines as parallel and this is our transversal. So if that's our transversal, then we could say that this angle A is 110 degrees. And the reason is, this is our transversal, this angle is our interior, this is exterior to these parallel lines, and that makes them corresponding angles. So corresponding angles. So now that we know A, we can say that's 110, and because angle B up here is vertically opposite, we can say angle B equals 110 degrees, and it's vertically opposite. And we could even label that it's the opposite angle A, which is, we already know, 110 degrees. So now let's have a look at C. Angle C. So if I look at angle C here, then we need to discuss the fact that these two lines are now parallel lines, and that this blue line is our transversal. Then if we look at finding angle C directly, we have the options of using alternate interior angles, because this is interior to these two parallel lines, which means we would need to know this angle, which we don't have directly yet. We haven't actually calculated it. And if we had this, then we also could use the angle out here, which would be using corresponding angles. So we don't have either of those, so we can just come up with another angle if we want to in order to help us find this. So let's just use, for example, B prime here. And if we're going to refer to an angle before we calculate C, we should calculate it here. So we're going to say that it's 70 degrees. And the reason it's 70 degrees is because it's a supplementary angle to angle B. And since angle B is 110 degrees, then what's left must be the 70 degrees to make a total of 180 degrees, because it is a straight line. So now that we have B prime, we can use it to say that angle C is also 70 degrees. And it is 70 degrees because it is an alternate interior angle and it's alternate interior to angle B prime. And finally, now that we have C, we can solve and get angle D, and I'm going to say that it is also 70 degrees, and for the same reason, it's alternate interior angle to angle C. And that's because if we have now our two blue lines as parallel, and we have this red line as our transversal, then C and D are both inside or between those two parallel lines and on opposite sides of the transversal, so that makes them alternate interior angles. And they are, as we know, the same. And here in our third and final example, we have to use angle properties to prove that lines are parallel. So it says that we have a cell phone tower, and we want to prove that this line, and this line are parallel. So we want to say that those three lines are parallel to each other. So to do that, let's start by breaking down and looking at just a section of this at a time. And to do that, I'm just going to look at the bottom line. So I'm going to just cover this up, and that way we can focus just on what we see down below there. So looking here, we want to prove that these two lines are parallel. So if these are parallel, we need a transversal. So I'm going to draw this line as our transversal, and that means that we can talk about angles that are interior or exterior to that. So what I see here is that if we have these two lines that are parallel, I see two angles here that are 22 degrees that are inside of these parallel lines. They are on opposite sides of the transversal. Therefore, they are alternate interior angles. So if, again, we set up our statement reason table, and so my statement is going to be that angle F to B to E. So we're going to write an angle that way. So we'll say that angle F, B, E. F, B, E is equal to angle. And to get this angle down here, this 22 degrees, we look at B, E, A. B, E, and A. So those two are equivalent. They're both 22 degrees. And we don't really need a reason. They are the same angle. It says right on the diagram. So from that information, though, we can say that two lines are parallel. We can say that BF is not that symbol, but parallel is that symbol. So BF is parallel to AE. And the reason is that those two angles are alternate. Interior angles. And they're equal. And because alternate interior angles are one of the four ways that we can use to prove that two lines are parallel, we know that these two lines are parallel to each other. So now let's look at the upper portion of this diagram. That we're going to first have to determine that this line is parallel to this line. So we're going to say that that and that line would be parallel to each other. So to do that, let's again break this up a little bit and not look at the bottom this time. And we'll see if that top portion can help us at all. So what I see here is if you have two parallel lines, if those are parallel, we need a transversal. I see a transversal here. Actually, let's just make that less bold. If that's our transversal there, then again, I see alternate interior angles. Remember that Z that we can make? That means that if these two are the same, then these two lines are parallel. So again, we're going to use the same sort of proof here. So we're going to look at two different angles. Angle C to G to B. C to G to B is equal to an angle. So to get this angle in here, we have to go G to B to F. G to B to F. So they're the same, that's just given in the diagram, so we don't have to say that. Or if you want to, we could just say it's given. And then we can talk about two lines that are parallel. So CG, that line, is parallel to this line, BF. And the same thing we said before, alternate interior angles. And so now we've just proven that those two lines are parallel. So if that's all true, then we said that this is parallel to that line, and we said that this line is parallel to this line. So if the bottom and the middle line are parallel, and the top and the middle are parallel, then all three are parallel. And that is what we were asked to prove. So we can now go ahead and look at the problems in this section now, please.